Okay, so what you're seeing right now is just the end of the last example from the last video, where we, by hand, eliminated the xy term so that we could rotate this into a hyperbola, and eliminate that the x hat term, y hat term. So what I went ahead and did is actually looked at this on Desmos. So here I've graphed that equation, right? And it does look like a hyperbola rotated. It also looks like a rational function that we would have studied also last chapter. But then watch when look at my slope. Like again, where did these numbers come from? 1 over root 3 and negative root 3 over 1. If you think about the slope of this line right here, let me highlight that for you. Like right here, right in that triangle, that's our angle of rotation, and it has a rise over run of 1 over root 3. So I just did that as a positive slope, and it cuts right through the line of symmetry, something perpendicular to it, opposite reciprocal, and there it is. So again, the power of Desmos is fantastic. It can graph the heterogeneous xy terms like nothing. But it is neat to regraph this to see that we do in fact get that particular hyperbola conic section. Okay, now, so what happens like if you don't want to have to go through all that work to determine what conic sections you have? So it turns out it has everything to do with the discriminant, which is under the quadratic formula, which I don't feel that strongly about the quadratic formula. But remember the discriminant, is the part that would have been under the square root, which is this b squared minus 4ac. So it turns out that this discriminant predicts and tells us what kind of conic section we have. And so, and it's the same three coefficients that are in front of the quadratics here. So if we did b squared minus 4ac with this example, so b squared, 10 root 3 squared minus 4 times 11 times 1. So b squared, so we're just trying this out. So 10 root 3 squared minus 4 times 11 times 1. So that's 300 minus 44. So the fact that it's equal to 256 is not what is important, but the fact that it's bigger than 0 is. When your b squared minus 4ac is bigger than 0, your conic section with that rotated term will be hyperbola. Okay, now we had one that was a parabola earlier in the example. Let's see what that b squared minus 4ac is. So that b squared minus 4ac was, let's see, negative 4 squared, so 16 minus 4 times 1. So negative 4 squared was, so we have negative 4 squared minus 4 times 1, which was 0. So it must be when the discriminant is equal to 0, we get a parabola. So if I think about what's missing, right? If when b squared minus 4ac is greater than 0, it's hyperbola. When it equals 0, it's a parabola. The only other thing it could be is it's greater than 0. Sorry, that was awkward. When it's less than 0. And then, of course, we have an ellipse, which, remember, a circle is a very specialized kind of ellipse with no eccentricity. Okay, so now, what I'm going to share with you is a source that kind of explains why the discriminant is what allows us to measure that. And so that is actually on this website here. And so certainly you can take a screenshot if you would like of this, because I think it's a good point. Like why would we want to look at this b squared minus 4ac? And so they get, I mean, this is great, right? They're completing the square, right? And they're basically rewriting this particular three quadratics. And you could do this as an exercise. This is great. But what ends up happening when you complete the square is that you get two quadratics. One of the quadratics is always positive, and one of them the sign of that quadratic fluctuates what kind of conic section you have. And so, that b squared minus 4ac just turns out it is the discriminant. Need a short break? No, not at all. Okay, so this was a super short video because it just gives you this idea of the discriminant. So now when you look at homework exercises like this one here, the first row of homework, you don't have to actually do the entire rotation process. You could just do your discriminant. So that was kind of the point of that. Okay, so I wish you luck in solving these. Be careful, be neat, and come in if you have any questions.